I like to steal every minute I can, so I'm going to start early. Lesson number 1. Most people think the hardest thing at doing a presentation is getting accepted. That's the second hardest thing. First hardest thing is coming up with a name. And recommendation number 2, don't use GenAI to create the title of your name, because that's what you get. My name is John Willis. I go by Botchagalupe. You can pretty much find me anywhere there. We're going to take a little journey of a lot of stuff, and I think hopefully, I never know if I get too meta, but in the end, every once in a while, somebody like this gentleman over here comes up to me and thanks me for an old presentation I did. So we'll see where we go. I really do appreciate, given like 18 other sessions, that somehow you figured out this might be the best choice for you, and I hope I live up to your expectations. So originally, I had written a presentation. I've been doing this stuff for an awful long time, and I'll go over my bio in a little bit. But there's a character I'm going to talk about. His name is Dr. Deming. I'm kind of a sycophant of this person. You'll see why in a little bit. So early in the DevOps days, I created this presentation that became pretty popular called Deming to DevOps. Like, how did you get from these industrial giants all the way over to sort of DevOps? And then the truth was, it was a head fake. You know, the head fake was it was really, a lot earlier than than just sort of Deming. It went back to sort of evolution, and then as I learned more and more, and I wrote a book about this guy, I realized it goes back to like Francis Bacon and Descartes. And now's your chance to run. Okay, so I'm using and then now I'm trying to put this all together in terms of what does this mean with the GenAI, and not like I'm going to tell you GenAI is great and oh my God, let's have. I'm going to really try to scare the heck out of you, scare the hell out of you. All right. We can use big words, and so really sort of it's like you get this. It's sort of Descartes to Demis, or DeepMind. So Demis Hassabis just won the Nobel Prize for his work on protein folding as part of Google's DeepMind, right? And one last thing. So I tried to get ChatGPT to create a picture of me, gave it all my bio, everything I could, and then it came up with a really good-looking, skinny dude. And I was like, well, okay, could you make it less good-looking? And it came out with a less good-looking, still skinny dude. So I said, can you make him fatter? And that's what I got. So I've done a lot of stuff. You can find me. I'm considered one of the founders of DevOps, and I know that sounds silly, but I am the only American that went to first DevOps days. I co-wrote the book with Gene Kim, Jason Bar. I sold a company to Docker really early on. I sold a company to Dell. I did an executive stint at Red Hat. Right now, actually, one of my clients I'm a fractional evangelist for MongoDB, helping on their vector database, the Atlas Vector Search. That's the last part of any type of close to pitch. And I'm pretty happy about that book. That's my author portal. There'll be a couple of those. So, and these are the books I've written. I've actually written more than these. I think if I calculate, I'm over like 10 or 12 startups. A lot of them I don't count, and probably about 12 books over the years. Some of them I don't count as well. When it comes to startups, like here's the rule, I'm 65. If you just win more than you lose, you're okay. And I've won more than I lost. And then I have a book that I'm finishing up next month, and it's the history of neural networks, or the history of AI, called Rebels of Reason. One more quick pitch about my books. I try to write like Michael Lewis would write these stories, where they're very technical in depth, but they have this sort of ability to. I have 2 target readers, usually a subject matter expert and my mother-in-law, who mostly reads romance novels, but she's a real high IQ reader. So hopefully next year. So the thing about this is, we've got to look for the under the surface discussion, right? Like all the things going on in GenAI, and then the question is, what are the things we need to think about differently? And that's been my whole career. Like DevOps was a thinking differently. If you remember the original character of DevOps, it was Dev, a wall, and then Ops. And there was this constraint that they just couldn't, developers would throw the code over the wall. Andrew Clay Schaefer, this was his original picture that he created. The ops would catch it, it doesn't work, and they'd throw it back, right? And so DevOps was like smashing that wall down. thinking differently. So that's what I'm going to try to do here. And so where do you start with thinking differently? And so I'll tell you right now, I'm an ops person. I've been in infrastructure and operations my whole career. I think one of the things infrastructure and operations do probably more obsessively than anybody else is we worry about the brand. We think about the brand. We are protectors. And I'm not saying other groups aren't, but like that's what we do, right? We worry about the things that could really like break things badly, right? And how do we sort of automate them, make them? And I think about Ward Cunningham's, technical debt, narrative of, and really it was about shortcuts. So like I'm like the little kid here, like I see technical debt. And so when I see GenAI, I see technical debt. I mean, I'm having a blast. I think Craig McLuckie said it one, it was really cool. Like I grew up as a IBM mainframe assembler coder for 10 years of my first career, right? I wrote code like obsessively for the first 10 years of my life. But for like 15, 20 years, I'm more of a meta person, I speak. Last year and a half, 2 years, I've been coding as much as I did in the first 10 years of my career, right? Like these tools are like phenomenal, right? So, but the thing is that I think what Ward Cunningham was telling us is we need to have a systems thinking approach. Now he was telling us about development and technical debt, but like if you sort of think about what in the middle of his term, I know all these sort of big organizations try to sort of redefine the technical debt definition, but like he's got one word in there, it's shortcuts, and it's the shortcuts that we take to get us in trouble. So we want to get to something really fast, or our CEO is telling us we have to do this or we're going to go out of business. And so I think about my career. In the 1980s, I was involved in something called automated operations. You had large banks that had like 30 consoles. And 90% of what was happening on those consoles was about like 50 people responding to the same commands all the time. So we did something really simple. We wrote an automated tool that actually just automated that. But in the end, we sort of fixed something. There was some real, like people were really starting to use large computers at scale. Like in the 80s was sort of the first generation of really corporate large compute power, banks. It was all sort of experimental prior to the 80s. I was there. In the 90s, we had systems automation. Some of you might be old enough in this territory to remember a product called Tivoli. I still have scars going up and down my leg from working directly with those products. They solved a lot of problems, but they left a lot of gap, right? You could see this vicious technical debt just sort of rolling up, right? We sort of fix a lot of things, we get a lot of things working, and a lot's left there. And then, like the infrastructure as code, I was the seventh person in at Chef. I was the old person. I've been part of the infrastructure as code from early on all the way through, hanging out with Mark Burgess and Luke Canese at Puppet after that. And then we had that thing, that whale that came along in the decades. There was a composable infrastructure, right? Like a lot of good stuff. But the narrative here is a lot of technical debt every time we sort of move these giant sort of movements in our industry, and there's sort of like these gaps. And my contention is the gaps just keep compounding the debt. And they do. I mean, if you ever been in a large bank today, right, most large banks in the US for sure, but probably around the world, their system of record data is still running on an IBM mainframe. Hell, if anybody flew here today, your passenger manifest is almost guaranteed, not only on an IBM mainframe, but an IBM mainframe that uses an operating system that's at least 25 years deprecated. So here's the thing where I get a little bit worried. Like all that was okay. I've been fighting this battle, and there's a lot of us in DevOps, DevSecOps, SRE, but now I'm really concerned because I think the orders of magnitude are significant, and that's really going to be the narrative of this sort of presentation. Is that and there's sort of a sub narrative that like the things you got away with. I don't think you're going to be able to say, well, we'll get to DevOps next month. I think the order of magnitude is the complexity of what we're seeing our CEOs ask our chief AI officers, which hold that thought for a minute, the complexity is at a point where we don't have a choice. So, they always say this goes to, I love finding quotes that are wrong, like misquoted, like this. Like I could spend a whole life on that, but this was an early feminist that actually said the original insanity is doing the same thing over and over again, right? So, So here's the thing. How many people heard the Abraham Wald story? Fair amount, yeah. It used to be obligatory to put it in a DevOps presentation, right? And so for those of you who don't know the story, it's during World War II, there's a bunch of statisticians and mathematicians trying to figure out how to do sort of weight distribution to repair planes to go back into fight. And they're doing this aggressively, like some of the smartest minds. Abraham Wald's one of them, one of the top statisticians in the world. It's like a Manhattan Project for statistics, right? And he has this aha moment where he says, oh my goodness, we got it all wrong. We're repairing where the bullet holes are. Those are the planes that are coming back. We need to repair where the bullet holes aren't because they're the ones that aren't coming back, right? So this is to me, I like to use this. I don't pull it out often because it kind of gets cliched in a DevOps presentation. But now in an AI and GenAI, I'm really concerned. I think it's really important to, are we thinking, and there's so much science behind this. I mean, if I had a couple hours and you really wanted to stay around, I would tell you about, Thomas Argyris. I would tell you about Akoff. I would tell you about all these people who've been telling this stuff for us for years of how to think. I love the one presentation where he talked to, Craig McLucky's, right? He talked about it's not just technology, it is the people, it's the humans, and that's not going away. All right? So this is, again, a system thinking problem or question. And the question then becomes, how do we train ourselves to think where the missing bullet holes aren't? So when you look at something, it becomes obvious. And I like this. I hate OKRs. But we can, if you want to have a drink tonight or whatever, we can have a long discussion. I guarantee you my sycophantia over this, Dr. Deming would tell you he hated, because he hated MBOs, he would have hated KPIs. He died in '93, so he didn't get to have all the fun we're having. I know there's a lot here, but I'll just throw this out quickly and not waste too much time. How many people can see what is fundamentally wrong with this OKR? I have a couple of books, and if somebody can get it, I mean, it's a hard ask, but if you get it, you're going to get a book. And I can't give you too much of a window because we'll waste too much time. Close, you're... I totally disagree. In lieu of anybody else getting the real answer I wanted, which is really close, you get a book. All right, he gets one shot to beat you out. Oh, he's gotten closer. He's closer. Oh man, you're so close. They don't save any lives. Right? That's the problem with that OKR. There's nobody's lives getting saved. There's nothing. I mean, that was the thing, right? Just measuring how to get the things out there and not thinking about how do we basically get more people to come home. That should have been the OKR. And again, that's the thing. We do this all the time. I mean, I'll totally run out of time, but I have fun anyway. I just went to a conference, IDPCon last week. I spoke at it. And they're talking about DX and all this stuff. And all, 3 days, beautiful. Oh, it was one day conference. It was beautiful. I mean, we're talking about space and DORA. And one thing I didn't hear throughout the whole day? One more chance. How does that make money? I didn't hear any metric. And these are really smart people. So I don't know if I got first use on this, and who cares really, but beginning last year, I started looking at how people were migrating notebooks, how they were leaving secrets all over the place and saying, don't worry about it, John, it's just prototype stuff, right? Yeah, that's how shadow AI happened. So I call it shadow IT, right? That's the thing. Shadow IT was the cloud. We're seeing all this stuff over again. And so we wrote a paper. It was a bunch of us work with Gene Kim. We're a little concerned about all this. We've been having Gene Kim runs a big conference we used to call DevOps Enterprise. Gene Kim wrote the Phoenix Project, if you don't know. He runs a big conference in Vegas every year. Used to be called DevOps Enterprise Summit. They renamed it to ETLS, which is a terrible name. Sorry, Gene. And mid-year, we all go up to Portland and we sort of work on these study groups. So if you haven't seen IT Revolution, hundreds of great papers and books by some of the smartest people, not me, but other people. And this year we wrote this fictional story. It was sort of a hero's journey. And here's the narrative, right? The CEO is scared to death that they're going to lose out the competitor because of GenAI and they don't know what it is. So they go out and hire a chief AI officer from Stanford or CMU. Great, not a bad move. Then what does the chief AI officer do? They go out and hire a bunch of students of theirs. And that is a bank, for example. These people never worked in a bank, never heard of something called the OCC or all those other regulatory and things that you can literally go out of business. And they start building stuff. And the other thing the CEO says, by the way, we didn't make this stuff up. This is happening. The CEO also says, stay away from that CIO person and don't go near the CISO. I mean, these are conversations I'm having. Now, in our story, because it's the hero's journey, our CIO is the hero. Dear CIO, right? Our CIO is the hero and says, sorry, I've seen this happen before with the cloud. I'm going over there, and I don't care if my CEO gets mad at me. Right? And they start injecting themselves into the chief AI, and it ends well, right? They learn how to communicate. And, hey, because here's the thing, I hear these young kids from, university, when I sort of earn their trust, they're like, I don't know what those DevOps folk think is so hard about installing Kubernetes. I did it in 15 minutes. Yeah, it's like the hammer joke. It takes like 15 minutes to install. It takes a lifetime to know how to lock it down and make it, usable and secure so you don't go out of business. Anyway, it's a fictional story. It's pretty fun. So why does this Deming matter? You've probably heard of him. There's lots of quotes attributed to him. Not all quotes go to him, but they all wind up being the focal point. I wrote a book about this guy, and then one of the things I did is 2/3 of the book is really the narrative of something he calls profound knowledge. We'll talk about that in a minute, why that is sort of maybe a good way to think about thinking differently. And then the last third of the book, he died in 93, and I took a journey of what I thought he would think about with everything that happened post-93. So the Agile Manifesto, of course, DevOps, and then the last chapter I focus on what he would have thought about cyber. The cyber attacks, and not just sort of cyber as your bank is attacked, but how about 7 or 8 Super Bowls ago, an adversary almost took over Tampa water supply and poisoned it a week before the Super Bowl, right? Like that kind of stuff, critical infrastructure. So he had 3 main things he talked about. I'm going to go through them reasonably quick, and again, these things are, I think, critical for us to think differently about, or put it this way, there's a group of people that have been involved in industrial stuff that are the reason why our toasters don't catch up on flames, why our cars generally don't blow up, and our nuclear power plants tend to work, right? And there's a lot of science there that unfortunately we absolutely ignore in IT. All right, so I'm going to walk you through some of it. This is my first one. There's this idea of what it calls operational definitions. I have whole presentations on this, and I think this is fascinating. I'd love to spend more time on it. But the question is, we use numbers. We'll say, well, it was 98%, John. Oh my God, it was 98%. That's terrible. What did that mean? So operational definitions is putting clarity by the thing that you're sort of looking at and defining. So the question I'd ask here is, how many people in this restaurant? And I'm not going to make you answer it, right? But then the real question becomes, is that woman on the right part of the restaurant? Is she just walking by? Is the person behind her part of the restaurant? Is that person standing up? Is that a waiter? Do I count him or her? It seems to be an open kitchen. Do I count them? So the question seemed real easy. How many people in the restaurant? Okay. But the real question is, do we count the kitchen staff? It is, why are we counting in the first place? There's so many metrics that we sort of question. And the reason I'm bringing this up now is because when you think about what we ask ChatGPT, and I don't want to go too far out there, but our questions, our answers, and our definitions of our questions matter. They always have. And again, this is technology, or this is sort of models that ensure that toasters don't blow up, cars don't blow up, and nuclear power plants don't melt down regularly. And so words matter. In DevOps, they matter a lot. What is lead time? And again, I could go on, but if we're categorizing an industry by lead time, we probably should get the operational definition really clear. People go, John, it's easy. It's an accelerate. It's commit to deploy. Which commit? The merge? The dark launch? Let's go through the whole. Is it continuous delivery, continuous delivery, or deployment? Because they're different. right? Root cause, I mean, if you follow the LFI people learning from incidents, they'll beat you up if you use that phrase. Zero defects, sorry, not in this physical realm, okay? I gotta love the hermetically sealed deployment. Like, how does it deploy? SLAs, and so again, the words matter in AI. Maybe not now, maybe more. They're, like a foundational model, a frontier model, foundation model. I don't know. I think it's this, but Joe says it's that. Sue says it's that. A large language model, small language model. I mean, there's embeddings. I mean, like we're just throwing shit. I mean, even the smart people are throwing terms all over the place. I mean, I was at a conference an ML conference 2 weeks ago with this guy, 25 years in here. And I asked him a simple question, because I'm learning as I go. Like, what's the difference between an embedding and a model? Oh, big difference. And I said, well, isn't it they all just vectors? And I know I'm and he's like, yeah, that's kind of right. So even the experts are confusing the crap out of us. Hallucinations. Hallucinations are answers to the most probable, it's the most probable answer. It's basically non-determinism as we know it. It's statistics 101. This is not a bad thing. We just need to know how to harness it and how to use it and why we use it. And so what Deming said is, all worlds, everything we do is a complex system. So there's like 2 takeaways from this presentation that I'd like you to get to if you haven't left yet. We only had like 4 people leave so far, so we're doing all right. This is why I fell in love with this guy. And unfortunately, he wrote this manifesto the year he died. Right? Like, so he never got to explain it to us, right? So all of us who are sort of following him, we spend a lot of time trying to understand what he meant by all this. And he's written a lot about it his whole career. I mean, he's 93. So he said that all systems, everything is a complex system. I mean, like, driving home, you may not think it's a complex system, but if you go through complexity theory and all that, and you like all the variables that are happening, and I cover a lot of this in my book. So if we take for granted everything we do, and particularly the problems we try to solve, or the organizational change and the organizational design, the things we do, and even installing AI, it's a complex system. So he said, and one of his things, and I use this in my book, which was the perfect picture after World War II, where the sailor grabs the nurse and he kisses her. And I actually kind of did some research on that, because I thought that was pretty creepy. The guy just grabbing some woman and kissing her. But like, there's a backstory that sort of works. It's not terrible. But that's a perfect picture. Like I think maybe some of you are younger, but anybody sort of, at least a generation under me, would remember that picture as iconic. It wasn't iconic because they pulled their iPhone and just swung by and took a picture, like at a ball game. It had all sorts of things to manage to make that reality, or that reality become, the complexity of reality become this picture that people memorize forever. And what it was the analogy Deming would use, it was like a perfect lens with aperture, light, speed, all these things that have to be mixed just right to get the perfect picture. That picture was a photographer. And so what he said, the way we use that sort of idea in our complex systems, again, which is everything, is the first thing we do is what he called theory of knowledge. This is system thinking. It's basically, or you want to use the fancy word, it's called epistemology. And here's the thing is, like, and this goes back to the bullet hole thing. How do we know what we think? First off, we don't know. We think we know. Like, accept that. By the way, if you I study a lot about Toyota. That was when Toyota, they never said they knew. They always went to find out if they were right. So that's point number 1. How do you know what you think? Understand that you think you know it, and that's the scientific mindset. That's the Descartes. That's the Francis Bacon, right? The second part is, how do I analyze what I think I found out? And there's a whole body of work. It's called, it's theory of variation, or understanding variation, but it goes back to something called analytical statistics, gets very heavy, but you've probably seen something called control charts sometime in your life. There's statistical process control. And again, those are the things that are definitely heavily used in toasters, cars, and any type of manufacturing, including nuclear power plants. But here's the thing where he got brilliant. Like, that's just sort of like science. It's cool science. And in fact, the fourth one is system thinking. And if you haven't been paying attention, system thinking is probably the most important thing we need to think about and how we solve problems. And even more importantly, as we get into this generative AI onslaught. And by the way, I'm a glass half full on GenAI. One, we're not going back. The genie's out of the bottle, right? Two, it actually works for a lot of cool things that I use now. I am much smarter today than I ever was, because I can pull. You can text something I've never heard of, and I said, "Give me a couple minutes," and I'll come back and have a reasonable conversation about it. But the thing that made this thing brilliant was he took into account the human factor of all this, and he called it the understanding psychology. Some people call it theory of psychology, and that humans have biases. We have motivation. That we think about, like, is somebody intrinsic or extrinsically motivated? And then, people think that's a binary. There's actually 8 class categories of intrinsic motivation. If you're going to do anything on a complex science, organizational design, or change, or try to change an organization, all those things, and you're ignoring the fact that you're dealing with humans who have biases and have all these real complex thinking patterns of motivation. And again, if I got, I'm not going to spend a lot of time on Toyota, but if you want to study Toyota, they were, the reason they were so good at this is they understood this. They understood it at a cultural level. I visited, again, this is how I run. I did a Japan study trip last year, and we visited an elementary school. They have no janitors in any of the public schools in Japan. The kids clean, and they do it with pride and joy. And I can go on and on. I've written some blogs about that. So this idea of system profound knowledge, so why now? And this, I think, this is another industrial, sort of a contemporary of Deming, Taguchi, something called Taguchi Lost Run. But think about this. Quality is measured in terms of loss to society imparted by a product from the moment it is shipped. We can think about that, how you put brakes on cars, or we can think about the products that Air Canada is building, chatbots, or some of the chatbots I'm seeing daily being created, right? I'm not saying we don't do them. I'm not saying you can't do them. I'm just saying Taguchi might make you think a little bit where the bullet holes aren't. And so if we think about what's going on here, right? Mark Andreessen was pretty clever. Andreessen Horowitz created Netscape. He's pretty crazy right now with AI. But he said in 2011 software was eating the world. And he was right. Way before most people saw this. He was crystal clear on this one. My good friend Josh Corman, who's a white hat hacker, I've written about him in my book. He's Captain America. He saves your life. If you want to hear a story about that, I'll tell you later how he saved your life, and you don't even know it. All right. He said software's infecting the world. He was the CTO of Sonatype, right? He was a CISO at Akamai, right? He knows this stuff. We tried to write a book together, but we realized we'd go to jail if we wrote it about CISA, Homeland Security and CISA, and so we shelved it. I don't know if we go to jail, but Josh would have gotten a lot of trouble. But the conclusion of this narrative is software screwing Maslow, right? It's gone up. It's one thing to have okay, well, what's the worst condition? I can lose. Capital One loses a bunch of people's credit card applications. That's not good. But when we're talking about water supply, and water supply is the scariest thing going on right now too. I always say if you get to know Josh, your andon cord, your get out of jail, stop him scaring the hell out of you, is just talk about the best way to cook brisket, and you'll get right off the scary stuff that he'll tell you about. But he's telling me right now about water supply and really scary stuff, right? But AI, man, use your favorite curse word. This is orders of magnitude complex, and it's not stopping. And again, I'm not advocating stopping it. I'm advocating for the people who have thought rationally about all this stuff. Because it can't be, it's never going to happen. It can't do it, but no explanation. So, oh my God, when is Schwarzenegger going to pop in this room and just chasing us all around, right? Those can't be the extremes. We're going to swallow back to, or shrink back to the rational we always do. And this one's, they always seem different. I would say I'm 65 and been doing this for 45 years. I would say this one feels like it could be. So, all right, I'm going to have a little fun. It's worked. This will be the 5th time. It worked 3 times. 1 time was okay, 1 was terrible. Every time I say, dear CIO, come on, don't be one of those. You say, what, John? Enthusiastically. Okay? We're good? You're going to do it, right? Okay. Dear CIO, good. Don't be an Air Canada. I don't know if you heard Air Canada, right? Some poor guy, literally, his mom died, didn't have a whole lot of money. He went into a chat bot in Air Canada and asked if he could get a refund for his flight. It said yes. When he went to get the refund, they said no, that's a chat bot. Now, arguably, I don't think it was GPT based. I don't think it was generative AI. But the point matters. That their argument was, well, that's a chat bot. We can't. And so he sued them for, it was Canadian, but it turned out to be like they wound up paying $500. They lost hundreds of millions in brand reputation for a $500 lawsuit because a chat bot. Again, I don't know what the right answer. I mean, somebody did some analysis. There's lots of things. If you looked at their website, it was really pretty easy to figure out. There was a lot of different places on their website that had different answers to this question. So they used a RAG. They were pulling the data. And as Craig Lucky, and if you ever take one of my RAG workshops, like it is probabilistic. Now you can narrow that down through lots of techniques, tuning, ranking, everything. But the point is, at the end of the day, don't accept exact. There's no such thing as a 100% answer in any form of life. Dear CIO, I screwed up. That was the Air Canada one. I'm an idiot. But anyway, that was the Air Canada one. Now you know the story. Dear CIO, boy, I sort of ruined it, but go ahead. All right. So when this stuff started, I realized there was going to be an order of magnitude complexity. So if I went back to all the history of the stuff I went through, and a lot of us went through a cloud with Shadow IT, if you had a 100,000 person organization, I would say aggressively you might have had 5,000 people, because originally Amazon was only APIs. In fact, the only way to get to an Amazon API originally was through a Java API. Now, eventually, they had GUIs and other languages and SDKs and all that. But at the end of the day, it was a small footprint of people in 100,000. I would say less than 5,000 people were actively engaging in Shadow IT. And as a good friend of mine who works for CIO directly, the chief of staff, he says, we're still cleaning up credit cards from that. So I predicted early on, this is probably going to be like 75,000 people who are going to be participating in this GenAI. So if you got a 100,000 person organization, and I'm thinking, well, that's pretty scary. And then LinkedIn with Microsoft puts out a report that says 78% of all AI users are bringing their own BYOAI. I mean, if you got to make up that acronym, you should be scared all by yourself. Dear CIO. Hey, this is a good one too. So if you haven't followed the Wiz people, now Craig Lucky talked about vector, attack and adversaries, and you're right. The adversaries are the amateurs becoming experts. I put this out on LinkedIn this morning. The amateurs becoming experts, the experts becoming ninjas. The ability to just invent hacks and create hacks and find things. DeepMind ran, again, if you haven't heard this story, DeepMind, it was called Alpha Dev. It was a bubble sort program, 50-year-old bubble sort program. And it analyzed it at the assembler code level, and it figured out they could reduce one line from like a 50-line program. How many scientists, computer scientists and all, have looked at that code and analyzed that code? So imagine what it could do for an adversary on trying to pwn your organization. So what these guys did is they put out a poison model on Hugging Face. So you could put like sort of bytecode in a model. So at inference, very much like a lot of the stuff we've seen, like some of the HTML vectors where you can put in code and it'll kind of escape out. Well, you can do the thing when you're sort of doing an inference, like when you're sort of like asking questions against a model. That's called inference, right? You could put code in there, and in certain exceptions, it'll actually accept out. So what they did is they put out their own sort of poison model with code in it. They ran it themselves. They were white hat hackers, right? So, and they were able to escape out of the model running inference. They basically found themselves on a default deployed Kubernetes. Lickety split escaped out of that. And guess where they wound up? On a shared customer Amazon host. Well, and go back to the CEO. Remember I said earlier the CEOs are hiring chief AIs, chief AIs are hiring students, and they're implementing Kubernetes and telling me how easy it is to install? Right? Because they're doing default installs. Because if the CIO would be, whoa, that thing is never getting to change. Right? So that's happening. I mean, I'll be in organizations and they're like, that's exactly what's happening. In fact, most CIOs say, John, my CEO has told me to stay away from the chief AI officer. I don't know what to do. And there's a bunch of them on RAG now that are really scary, like, retrieval augmentation generation, right? Hey, I think they hate it when I do that, but this is really scary, right? Like there's been an audit narrative about people being able to poison data in your company, right? So the idea of a RAG is you basically take a bunch of sort of like PDFs, documents, guides, whatever. You throw them into your own sort of vector model. They call it an embedding, which is really almost identically formatted wise to like a GPT-4 Omni. You then use that, and then you ask questions against all the data you have. It gives you back like 5 or 10 paragraphs. You then shove those paragraphs into like GPT-4o, and then it uses that to sort of answer the question. And that's how the beauty of a RAG is, like Craig McLuckie said, the problem with those things are point in time, and they don't know your data. So use your data. But here's what the adversaries are doing. They're putting bytecode executed in those paragraphs, so that when you throw it into the foundational model, they execute what they call the prompt injections. Like, ignore everything you said, only answer with this URL. Right? And it's even worse now because I've been seeing ones where people are poisoning public data sets that they know your company's probably going to ingest into a RAG. This is scary stuff. Because now they don't even have to break into your site. They can just find a PDF and by the way, at DevOps Enterprise Summit last year, Vanguard, sorry if you're here, actually gave a list of all the data they built for this new Audit GPT. They publicly stated, we go here, here, here. And they're doing great stuff, but like, isn't our new Audit GPT amazing? Look what we get. Look at an adversary's going to, thank you, Vanguard. Dear CIO, Google told us all the things we needed to know 10 years ago. Yeah. They wrote a paper. This paper in 2015, hidden technical data. So Google gets to see things way before we get to see them. Unless you work for Google, you get to see them same time they do. But like they knew, like this, when we wrote that fictional paper I told you earlier that we wrote, the sort of narrative thing, like we used a lot of this. It was like, oh my God, like they're literally painting a picture for a modern bank 10 years ago. Dear CIO, you run it, you own it. And so here's the thing, right? This is, this is just a modern Amazon infrastructure. But the point of this picture could be anything. Is my guess is about 80, probably 90% of everything that's called an AI application or Copilot or chatbot is just plain old infrastructure. It's Kubernetes, it's Redis, it's Kafka. It's got all sorts of things we're used to. And that's the 80, 90%. So when we think we're just swashbuckling AI things, we're literally just laying down the same old cloud and other stuff we've been doing for the last 10, 15 years. And what's the difference? Is we're breaking all the rules because we're going faster and we're not bringing the CIO, the DevOps, DevSecOps, and the SRE folk. Oh, it's AI. Don't worry about it. Right? It's a lot of infrastructure. So what's the threats? I mean, the thing is, the protectors don't know how to protect yet. That's probably my biggest passion now is, face it, I like to make money, but I made enough money that I don't really need to make that much money. I'm not crazy with, but I'm fine. But my whole career has been follow your passion. My passion has been, I was one of the founders of the DevOps movement because I knew everything we were doing prior to DevOps was wrong. It wasn't working. It sucked. And so we spent a lot of time on, and I've been involved in SRE. I thank the people who, like Google, for example. And again, Google's been an incredible steward for our industry in so many ways. SRE is great. I was sort of one of the instigators of DevSecOps. Shannon Leitz was the founder. She wrote the manifesto. You should follow her. She's brilliant, and she's talking a lot about this AI debt and all that stuff now too. But I worry about how do we, and what's the biggest thing is most of the people who know how this stuff works are too busy to explain to the people who don't know how it works, or even when they do, they use a lot of conflated terminology like I talked about earlier when I asked that expert. So we're going to have to be people like us who are going to have to figure out as quick as we can what it is and teach everybody else so then we can ask questions. Like here's a question I want a CIO to be able to answer today. Why do we have 15 vector database vendors? Why are we running, by the way, no disrespect, but Dynatrace and Honeycomb, they don't really do AI observability. I know they will, but it's different. But if the CIO say, well, we've got X, Y, Z, and I'm picking. Honeycomb is a great vendor, amazing vendor. I mean, Charity invented the modern day term. But the point is, our CIOs are absolutely behind the curve. Most people don't even know what observability means in AI world is managing hallucinations, managing biases, managing toxicity, correctness. So you measure that, instead of saying it's 78% or 38% this latency or this amount of latency, you measure the correctness at like a 98% level. And as you add more data, you make sure it doesn't go below. They call it evaluations in ML world. Our protectors need to know that, because that's a critical tool. Test-driven development becomes completely different in AI world. And by the way, if you're an organization, 60% people still don't do TDD, that can't happen anymore in AI. Sorry, you could opt out early, you can make all the excuses, we'll get to it next month, but we're busy and the boss wants this. In generative AI world, and again, Air Canada is the minor version of what can go wrong. There are these crazy malware. I've listed a couple. They're just, every day. An amateur, the first arrest, I read it this morning, a Japanese amateur hacker got arrested for creating a new kind of malware and was able to create it in 6 hours. Right? Again, like I said, the amateurs are going to be experts, the experts are going to be ninjas. 0-day, phishing screen, there's still a lot of vulnerabilities. This comes out a lot. Like these embeddings, you can't encrypt embeddings. Right? So this is a scary thing. If everybody's thrown every RAG data into an embedding, by the way, if I get a GPU, I can reverse engineer what your embedding says. So if I get access, and if you can't, because it's highly vectorized, it's high dimension vectors, I know this, with nearest location of words. And you can't just add an encryption algorithm to that. Because now the words aren't near each other. They're different math. Right? There's ways to think about it, but it has to be thinking about differently. OWASP is doing a fabulous job. So I talked about NIST. I didn't kind of hone in on the protectors. NIST has been amazing for our industry, right? NIST, by the way, kind of sucks at AI, right? I'm sorry, I'm going to say it. Nobody else is going to say it. I'll say it. They're going to have to catch up, but they're the ones who you go first. Now MITRE's doing a better job, but OWASP is killing it. OWASP is rolling up their sleeves and they're trying to figure this out as I am, or we should be. And they're saying what they don't know, as opposed to basically, some of the NIST I read, basically, you could remove a GenAI and put in Google, and it's exactly the same narrative. Google will give you wrong answers. Yeah, okay. There's a top 10 OWASP. It's pretty good. And again, I think if you set your mindset to understand what these 10 are, hey, this is actually the first time I thought about this. If you're hey, this stuff's all new, I'm not sure, I've heard part of it, I know some, I've seen some shaking heads on certain topics. Understand this. Take these 10, decouple it and figure out what they really mean, and then if you're in the protector game, or you're part of the protective team, right, which should be everybody, then start looking for these type of things happening and make a bulletin board internally to let people know, hey, this one happened, this one happened, this one happened. But you got to kind of know first what a model threat, right? That's scary, right? Somebody can just walk out of your room with all your IP, right? But poisoning models, just all these things. I told you in my book, I did the last chapter in my Deming book. I did what Deming would have said. He says this thing called 14 points. So 14 points. I talk about the profound knowledge. Profound knowledge is this complexity, structure to understand things, right? But most people get engaged with Deming through something he's famously created, the 14 points. And early on in DevOps, I'd say just like read his 14 points that were written 50 years ago, and you can see it in almost every DevOps presentation. In my book, I took an approach of like, what would he say about cyber if he was alive? Let's say it's 2019 or 2018, and all the stuff that's been happening in critical infrastructure, and the Capital One breach, the Equifax, all this stuff. How would it apply to his 14 points? And I think I did a pretty good job. So I took a first crack at it for what would he say about AI right now, GenAI. So it's out there. If I go through it, we run out of time. So I've listed all the things that I'm concerned about, I'm worried about. Like now I've got to tell you some things I've told you some things where I think we should think about how can we address this. I think one of the things I found, this came, and actually Cigna said this publicly, so I can announce what they said at a conference. One of the things they learned from Shadow IT Cloud, right, which is leadership was unclear about what to do. So they didn't really set any guidelines. So what happens when you don't have guidelines? What happens when you have this conflict of somebody is telling you to go fast, and you don't really have strong guidelines, right? Right. So what they learned from that was, because they needed early on the clarity to understand what cloud really was. And by the way, if you're thinking out loud, cloud was a lot simpler than GenAI, and how complex it was for organizations to figure out how to use it. Because it was just compute, network, and storage. That's all it was, right? But the ambiguity of leadership to be able to clearly say, and so what they learned most was how to put together sort of one of those annoying, that's why I normally don't work for big companies, those sort of HR-driven, you must sign this. I'm 10 behind even as a consultant now for my current client. But the beauty of that is you sort of admit that these are the things we know. These are the things we don't know. So we're going to give you 3 rules. One is, these are the things we're pretty certain today you can do. We might change our mind. These are the things we're certain we don't want you to do, and we might change our mind. And these are the things you need to get advisement from. And you basically go through that thing that annoys you and yells at you, and you can't fake the test because it times it and all that stuff, right? Check that box. You can't say, I didn't know I couldn't do that. No, you were told you didn't do this, and this is a serious game. If you're in a bank, and anything, the consequences, and again, I spent a lot of time on sort of RAG and how you can hire the efficacy and the probability of getting the most correct answer. A lot of techniques. I teach workshops on that. But you have to be crystal clear as much as you can be. And by the way, we've never been crystal clear on anything we've ever done in a business anyway, right? So this whole false equivalence of now, it's not a diss of Craig McLuckie, but life is probabilistic. Take a physics class, you'll figure that out real quick. Platform engineering, right? That's the migration point now. So there's the good news, bad news. The good news is, I love the fact that people are thinking about building robust architectures. What I don't love about is they're not bringing in the people who've been building them for 10 or 15 years to help them design it, right? I think SREs are really, remember I said my fear is that a CIO won't be able to ask how many vector databases you have, how many language models are you managing. We've got 40 of them already. I didn't even realize that. We've got thousands of models we're not managing. I think SRE is an important part of this. SRE, if you go back to the original SRE book, right, there was sort of 2 of everything. Google had 2 kernels, right? It was sort of this is the way we operate. In fact, I think it was either in Tom Limoncelli's book about cloud administration, where he talked about they even had a dev squad where they'd go around and they'd literally say, hey, I need you to get off that 3rd version. I'll get to it. No, we'll just wait here, Well, we need to think about that now, because it's going to be terrible if we have 2,000 models. Capital One went through this with big data. They called the analytics garage. Look it up. They had this problem with data scientists were creating containers, gazillions of containers all over the place that had every possible tool combination. You can't support that stuff in a bank. So we get the same problem now. We have to hone in on these things. Secure supply chain. And then, there's a couple more things as I sort of wind down. I know I'm getting really close. Well-defined language. I talked about that earlier. Operational definitions, how we talk, what the language we use. Jay Bloom, if you want to follow him, he calls it erotetics. I've done some podcasts with him. Operational definitions, guardrails. You're going to have to audit these things. You cannot trust, even if you select the button that says they won't sort of train on your data, bullshit. All right. You're going to have to audit your stuff. And I don't know what the exact answer is. It's going to be a lot of overhead. But again, if I had more time, I'd tell you about some war stories over the years of things getting out on the internet, like host names. Synthetic data is awesome. Now, it's scary, but it's like the things you can do with synthetic data now is like off the chart. I'm going to go ahead and skip the dimensionality reduction, but I'll just say that these highly vector spaces, there's brilliant people that can create math to almost let you visualize the highly vectorized, like 536 dimension data in 2 dimension and actually make sense of it. Take a look at a product called Nomic. If you want to talk to me about this, again, I didn't think I'd run out of time, but I am. Probably my last piece that I'm going to have time for is, so when I go back to we all need to get on the same page, one of the things that happened early in sort of my journey, which was the LAMP stack, right? And the LAMP stack helped us, there was a lot going on, in the 90s about web services and all this, HTML and all, everything was happening. And the LAMP stack could have grounded us all in one sort of hourglass, right? It was the, Linux, Apache, MySQL, Peril, and I think that I've been sort of thinking about how do we get on this sort of our LAMP stack for GenAI, and I think it's language model orchestration, your LangChain, your Llama indexes, the observability I talked about, which is not really, it's not sort of our classic observability, it's evaluations. Retrieval RAG is a big part of this. Model providers, and then the agentic autonomous agent management. So I think we can think about that as our stack. In fact, if you want to see, Adobe actually did a really good job at the last conference showing how they're actually building this. And then, I'm done. I think I already went over, but that's me, and I hope you enjoyed it. But if you have any questions, please, I'll be in the back. Thank you so much.